In the following video, we're going to examine the three different ways of describing a function. We can describe a function as being one-to-one, onto, or both one-to-one and onto. So let's first look at just the one-to-one. If a function is one-to-one, that means each element in the domain pairs exactly with one unique element in the range. So remember, domain are the x values and range are the y values. So you can read this as every x value, each x value is paired with exactly one unique y value. So if you look at what this looks like as a mapping, these are my domain values, these are my range values. So these are my x, these are my y. This x value of 1 is paired with exactly one unique y value. The 2 is paired with exactly one unique y value, and the 3 is paired with exactly one unique y value. So each x has exactly one y. If we examine the mapping further, we see, though, that there is a range value, an element in the range, a y value that is all by itself. There is no x attached to it. And this is what is unique about one-to-one functions. For us, when we study one-to-one functions are going to occur when we have a mapping where there is an extra y value that is not attached to an x value. So when we are looking at it, we can see it does fit the one unique y value with an x value. Each x has exactly one y. However, for a one-to-one function, you're going to have an extra y value that is not paired with an x. Now, an onto function is the next way to describe a function. For an onto function, each element in the range corresponds to an element in the domain. So remember, your range represents the y values. So my range is here. My domain is here. So each element in the range is accounted for. It corresponds to an element in the domain. So each element in the range is paired up with an element in the domain. However, for an onto function, a y value can be paired with more than one x value. And we can see that occurs right here in our mapping. The y value, c, is paired with both the x value 3 and with 4. So if I were even to say, let's write this as coordinate, my 3 is paired with c and my 4 is paired with c. So I notice that the c value corresponds to two separate x values. The y value corresponds to two separate x values. This is the characteristic of an onto function. For an onto function, a y value will have multiple x values. A y value will have multiple x values. And make a note for this, when you are, this point is for graphing, when you start to graph and you want to determine if something is an onto function, one way to look at it is if it fails the horizontal line test. Which a vertical line test says that if you draw a vertical line through a function that intersects more than once, it's not a function. If you draw a vertical line through a graph and intersects more than once, it's not a function. For an onto function, if you were to draw a horizontal line through the graph and it intersects more than once, then it fails the horizontal line test, which means it's onto because it'll have more than one x value paired up with a y. So that is our onto functions. For both one-to-one and onto, each element in the domain, each x, is paired with exactly one element in the range, a y, and each element in the range corresponds to a unique element in the domain. In other words, no element in the domain or range is shared with another ordered pair. So if we look at this one, we see everything is accounted for. They're all unique and they're all paired together. Each x, each element in the domain, is paired with exactly one element in the range, and each element in the range, each y, is paired with exactly one x. So when you're trying to figure out if something is both one-to-one and onto, you're going to have to ask yourself, does it meet both characteristics of a one-to-one function and an onto function? And the easiest way to do this is if it passes both the vertical and horizontal line test. If it passes both the vertical and the horizontal line test, which means they intersect only once when you sketch a vertical line, it intersects only once when you sketch a horizontal line, then it's going to be both one-to-one and onto. Let's go over briefly the characteristics of each. So one-to-one means each x is paired with exactly one unique element in the y. However, you'll have an extra y that is not paired up with an x. This is going to occur in a mapping. There's no way to plot a y point without an x point attached to it. So we're going to see more one-to-one functions occur in a mapping for us than as a graph or a list of ordered pairs. Oh, an onto function means you're going to see a y value that is attached to more than one x. That's the characteristic you look for in an onto function. For the both one-to-one and onto, you need to make sure that it's unique in both directions. Each x is paired with a unique y, and vice versa. Each y is paired with a unique x. Nothing is left not attached. And we look at it as a graph. If it passes both the vertical and horizontal line test, then we say it is both one-to-one and onto. For more practice or for a helpful guide for this, there is a handout posted online for you to access that provides even more explanations of a one-to-one function, an onto function, and a both one-to-one and onto function. And it tries to describe it in more basic terms than mathematical terms. So if you need more practice or understanding, please go online and access that handout.